Welcome to our four-part series on economic modeling. In this video, we will learn how to build and interpret a simple supply and demand model for the market for beef. We begin the model building process by specifying the variables that we think are important in both demand and supply. If you remember from your Principles of Microeconomics classes, there are a standard set of variables that economists believe that are important both to demand and supply. Let's begin with the demand equation. The following variables are important. The first one is what we would call the dependent variable, which is the quantity demanded of beef itself. The other variables we would classify as independent variables. The first being the price of beef. The second being the price of any substitute goods for beef. Third would be income. And finally, we could specify any other variables that are specific to the demand for beef. After listing out the important variables and classifying them as either dependent or independent variables, the next step is to specify the algebraic form of the demand equation. The following equation is a simple algebraic representation of how the variables fit together. The dependent variable, the quantity demanded of beef, goes on the left-hand side of the equation, while the independent variables, the price of beef and the price of pork, go on the right-hand side. This is a simple linear specification of how the independent variables affect the dependent variable, the quantity demanded of beef. If we repeat the process with respect to the supply equation, we would have the following set of variables. The dependent variable would be the quantity supplied of beef, while the independent variables would be the price of beef, the price of inputs, technology, and any other variables we think are important. As with the demand equation, the next step is to specify the algebraic form of how the variables fit together. The following equation is a simple specification. We put the dependent variable, the quantity supplied of beef, on the left-hand side, and the independent variable, the price of beef, on the right-hand side. The two equations, the demand equation and the supply equation, are our algebraic representations. We've made our model very simple in the fact that we've ignored the income and any other variables in the demand equation, and we've ignored the price of inputs and technology in the supply equation. Again, the purpose of this video is to illustrate how the variables fit together. The next step in building a model is the interpretation phase. If you recall from the previous slide, we have our algebraic representation of the demand equation and our algebraic representation of the supply equation. The next step is to interpret what all of this means. The interpretation is very important, and in economics we call these the marginal effects of the model. Marginal effects relate a change in the independent variable to a change in the dependent variable. They are simply the slopes of the equation. If we turn our attention to the demand equation, the first marginal effect would look like this. It would be read as the change in the quantity demanded of beef divided by the change in the price of beef is equal to -3. Again, this is the slope of the equation holding everything else constant. The -3 comes from the demand equation, and it is the coefficient attached to the independent variable, the price of beef. The second marginal effect relates a change in the price of pork to a change in the quantity demanded of beef. Here it is equal to 1. Again, remember there's an implied 1 as a coefficient attached to the price of pork. So for the demand equation, we have two marginal effects, or two slopes. The first is equal to -3, and it relates a change in the price of pork to a change in the dependent variable, the quantity demanded of beef. The second relates a change in the price of pork to the dependent variable, a change in the quantity demanded of beef. If we turn our attention to the supply equation, we have one marginal effect, given that we only have one independent variable in the equation. It is the slope, and it specifies that the change in the quantity supplied of beef with respect to the price of beef is simply equal to 15. Again, the 15 is the coefficient attached to the independent variable, the price of beef. After writing out the marginal effects in algebraic form, it's important for us to understand what they mean in plain English. The first marginal effect would be interpreted in the following manner. We would say for every 1 unit increase in the price of beef, we would expect the quantity demanded of beef to fall by 3 units, all else constant. Here we have an inverse relationship between changes in the price of beef and the quantity demanded of beef. This reflects the law of demand that we learned in the principles of microeconomics. It happens to be equal to 3 in this case. The all else constant plays an important role in economics. Since we have two variables in the demand equation, what we must do is hold all of the others fixed when we interpret the marginal effect for the price of beef. In effect, what we are saying is that if we hold the price of pork constant, then if we increase the price of beef for, say, $1, we would expect the quantity demanded of beef to fall by 3 units. The second marginal effect in the demand equation would be interpreted as follows. For every 1 unit increase in the price of pork, we would expect the quantity demanded of beef to increase by 1 unit, all else constant. Again, the all else constant plays an important role. Here, what we are holding constant is the price of beef. Notice that we now have a positive relationship between changes in the price of pork and changes in the quantity demanded of beef. This reflects the fact that pork and beef are substitutes in consumption. If the price of pork goes up, we would expect the consumer to substitute out of pork into the less expensive good, beef. The marginal effect of the model captures that substitution. The final marginal effect relates to changes in the price of beef and changes in the quantity supplied of beef, and it would be interpreted as follows. For every 1 unit increase in the price of beef, we expect the quantity supplied to increase by 15 units, all else constant. What we're specifically holding constant in this case, again, is the price of pork. However, notice that we now have a positive relationship between changes in the price of pork and quantity supplied of pork. This reflects the law of supply that we learned from principles of microeconomics. That concludes our video 1 of part 1 of our series on economic modeling.